Hello everyone. Today we are going to start our new chapter for class ninth, that is gravitation. About gravitation you have already learned many things. We have already know the Sir Isaac Newton who found that the gravitation and about the gravitational force which is applies on each and every object in the universe. He gave one theory, one law about the gravitation, which is known as the universal law of gravitation. According to this, you have to learn at least 3 point or 3 sentence. First one is that the every object in the universe attracts every other objects. Second one, the gravitational force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. It is applicable in the universe each and every objects. So basically you can calculate it and find that F equals to capital G m1 m2 divided by r square, whereas capital G is gravitational constant with value is 6.673 into 10 to the power minus 11 Newton meter square per kilogram square. M1 mass of one object, M2 mass of another object, and the r square, r is the distance between two objects. Importance of universal law of gravitation, which is applicable to each and every object in the universe. So first important importance is the force that bind us to earth, the motion of the moon around the earth, the motion of planets around the sun, and the tides due to the moon and sun, high tides and low tides, which you have already studied in the SST also. Next one, free fall. What is the free fall? If any object is fall from a height under the influence or under the gravitational force, that is known as free fall. During the free fall, the initial velocity of the object is always 0 and the gravitational acceleration, that is the small g, is taken as positive because object is falling towards the earth. So when a body is falls towards the earth under the effect of the gravitational force, then it is called free fall. How we can calculate? If any object is near the surface of the earth, then the distance between the object and the earth is equals to the radius of the earth. So the d or the small r will be converted into the capital R. So the small g equals to gm upon r square. Sir, यहाँ तो f था. Where is f? So f, according to the second law of motion you have already studied in the previous chapter, the motion and the force and law of motion, in which according to the second law of motion, that is the force is the product of mass and acceleration. So F equals to ma. A is normal acceleration. Here is we are using the gravitational acceleration, so the a is converted into the g. Small m small g equals to capital G capital M small m divided by r square. So m to m both side cancel out हो जाएगा. So remaining will be small g equals to capital G capital M upon में r square. And the for earth, the value of small g, that is the gravitational acceleration on earth, is 9.8 meter per second square. If the same data will be calculated for the moon, then the gravitational acceleration on moon will be 1.63 meter per second square. Next, equations of motion. तो इक्वेशंस ऑफ मोशन में हमने ऑलरेडी पढ़ा हुआ है. लाइक फर्स्ट इक्वेशन हो जाती है अपनी v इक्वल्स टू u प्लस ए टी. Here is we are using the gravitational acceleration, so a will be converted into the small g. In the second equation, we have studied s equals to ut plus half AT स्क्वायर, अगेन ए कन्वर्टेड हो जाएगा GT में। सर एस, तो एस आपका कन्वर्ट हो जाएगा हाइट में। एस मीन्स डिस्टेंस बिटवीन द ऑब्जेक्ट्स, सो हियर इज object is falling from a height or an object is thrown upward vertically, so the distance will be converted into the height, and same will be repeated in the third equation, that is v square equals to u square plus 2gh. This equation we have written in that format, like 2as equals to v square minus u square. So here is some changes, like s equals to converted हो जाएगा third one, that is v square minus u square divided by 2a. Again a will be converted into the g, s will be converted into the h. Next, g is taken as positive when the object in the direction of motion or the downwards, and g is taken negative when object is thrown vertically upward. सिंपल सा है कि अगर ऑब्जेक्ट आपका ऊपर से नीचे गिर रहा है, ग्रेविटेशनल एक्सेलरेशन भी आपका नीचे है, इट मीन्स both are having the same direction, then the small g, that is the gravitational acceleration, will be taken as positive. And in the same situation, initial velocity will be taken 0, because object is falling free fall from a particular height. It means there will be no initial velocity is required, so that is 0 meter per second square, sorry, meter per second. Then next, if an object is thrown vertically upward, कि किसी भी ऑब्जेक्ट को आपने नीचे से ऊपर फेंका है, और ग्रेविटेशनल एक्सेलरेशन तो ऑलवेज कहाँ लगता है, डाउनवर्ड्स. सो हियर इज स्मॉल g is taken as negative, and in that case final velocity will be taken as 0. So everything is very easy. If you focus with some more intensity, then you can learn the things easily. Next, that is mass and weight. So here is some basic differences between mass and weight. That is, first one, mass is your scalar quantity. It does not change according to place. It remains constant everywhere, and the SI unit of mass is kilogram. Whereas in weight, the object is a force with a force attracted towards downward, or due to the gravitational force, the weight is a vector quantity in which a direction is also required along with the magnitude. So the SI unit of weight is same as the force, that is Newton. It varies from place to place, and its value becomes 0 at the center of earth. We know that F equals to ma, that is equals to the mg, and this force is known as weight of the body, and the weight of the body is denoted by the capital W, which is replaced by the force, and the final formula we get that W equals to mg. It acts vertically downwards, so it is a vector quantity. Next one, when of an object on the moon. सिंपल है, बहुत ही ईजी सा हो जाएगा हमारे लिए. लाइक ऑन ग्रेविटेशनल एक्सेलरेशन ऑन अर्थ इज 9.8 meter per second square. Gravitational acceleration on moon, that is 1.63 meter per second square. Again, if you calculate the value or the ratio between the gravitational acceleration on earth and moon, then we will get that gm divided by ge equals to 1.63 divided by 9.8, and the value of this we will get is 1 by 6. In the next step, the g will be transferred the other side, then it comes in the multiplication form. So the value of the gravitational acceleration on moon will be 1/6 of gravitational acceleration on earth. If we add the mass along with it, then this gravitational acceleration will be converted into the weight of an object on moon will be 1/6 of the object's weight on earth. सिंपल सा है कि आप सोचिए कि एक ऑब्जेक्ट का वेट अगर 60 किलोग्राम 60 न्यूटन है अर्थ पे, तो उसका मास पे कितना मून पे कितना हो जाएगा, तो 1/6 ऑफ अर्थ, दैट इज 10 Newton. In basic life, we are using the unit that is kilogram for instead of Newton. नेक्स्ट पे आ जाते हैं अपन thrust and pressure. Thrust is a type of force which is a perpendicular force acting on the surface of a body is called thrust. कोई भी ऑब्जेक्ट पे अगर आप परपेंडिकुलर फॉर्म में अगर कोई भी फोर्स एप्लीकेबल होगा, then it will be known as thrust. And the SI unit is also similar to the force, that is Newton. And what is the pressure? In 8th standard you have already studied about the pressure. What is the pressure? A force acting per unit of the body is known as pressure. So pressure equals to force upon area. So it is also denoted by the pressure equals to thrust upon area. You can also write it as P equals to F upon A. So SI unit of the pressure is Pascal. You can also write it as Newton per meter square, which is also known as Pascal. The same force acting on the smaller area exerts the larger pressure and the smaller pressure on the larger area, because the pressure is inversely proportional to the area. If you increase the surface area, the pressure will be reduced, and you decrease the surface area, then the pressure will be increased. Next one, pressure in fluids. In 8th standard, this topic is already explained very nicely. What is the liquid pressure or the fluid pressure, which is measured with the help of manometer? All liquid and gases are collectively known as fluids, and a solid exerts pressure on a surface due to its weight. Similarly, fluids also have the weight, and they also exerts pressure on the base and wall of the container in which they are closed. Pressure exerts in any contained mass of fluid is transmitted undimensioned in all direction. It means liquid exerts pressure in all direction. Liquid pressure increases with the depth. And next one, buoyancy force, that is the force which is applied on an object in vertically upward direction opposite to the gravitational force. When a body is immersed in a fluid, it experiences an upthrust force that is also known as buoyant force. This phenomenon of fluid is called as buoyancy, and this buoyant force tending to the counter the balance the weight of this body acting vertically downward. It means if you place a plastic bottle in water, then water also apply some upward force, and the bottle also face a downward force that is known as gravitational force. In that case, the gravitational force is less as compared to the buoyant force, and the buoyancy force is more, so the bottle will be float over the surface of water. If the gravitational force is more as compared to the buoyancy force, then object will be sink. One more theory regarding the object, whether it will be float or sink, that is density. What is the density? The mass per unit volume is known as density. d equals to m upon v. If any object having the more density than the liquid or the substance which is already filled, then the object will be sink. If an object having the less density than water or the substance which is filled inside the container, then the object will be float on the surface of that substance. Next, why objects float or sink when placed on a surface of water? As we have already discussed it in the previous slide, if the buoyant force is greater than the weight of the body, it will float, and vice versa. It means if the gravitational force is more and buoyant force is less, then the object will be sink, like a rubber cock float whereas an iron nail sink. Archimedes' principle: when a body is immersed fully or partially in a fluid, it experiences an upward force that is known as buoyant force, that is equals to the weight of the fluid displaced by it. It means like एक कंटेनर में हमने वाटर लिया, उस वाटर में आपने कोई भी ऑब्जेक्ट को डाला, जो भी इस ऑब्जेक्ट का वेट होगा इन द इन्फ्लुएंस ऑफ ग्रेविटेशनल फोर्स और ग्रेविटेशनल एक्सेलरेशन दैट इज mg, ये ऑब्जेक्ट उतने ही सेम अमाउंट की वाटर को डिस्प्लेस करेगा. सो दैट इज नोन एज आर्किमिडीज प्रिंसिपल विच वॉज फाउंड और गिवन बाय आर्किमिडीज. Upthrust force or the buoyant force equals to weight of the fluid displaced by the body. So the body of the weight of the body in air minus weight of the body in fluids, we can easily calculate. Next, relative density. This topic has been excluded from the last year from our syllabus, so you are not required to study this topic. थैंक यू सो मच एवरीवन. मिलते हैं नेक्स्ट वीडियो के साथ, नेक्स्ट चैप्टर के साथ. थैंक यू.